So limits are actually the very first thing that we study in AP Calculus, but they are in the pre-calc standards. So we're just going to kind of skim the surface. We're going to look at some of the simple ones right now, and then when you take calculus, you will dive deeper into them. All right, so let's talk about, I just want you to consider this function. F of x is equal to the sine of x over x. If I asked you to evaluate that for x equals 0, what do you get? If I say evaluate sine of x over x for x equals 0, what do you get? 0? Is it actually 0? You get an error. Okay, well, why do we get an error? We can't divide by 0. Okay, when we plug 0 into this equation, we get the sine of 0 over 0. What is the value of sine of 0? What is the sine of 0? Come on. Sine of 0. Nope. 0. Okay, it is 0. So this is an even bigger no-no than just dividing by 0. 0 over 0 is something that we call an indeterminate form. Indeterminate form. We don't really know what 0 divided by 0 means because division is grouping. So how do you group nothing into no groups? So anyways, it's the indeterminate form. Just want to throw that word out at you in case you hear it or see it somewhere along the line. So 0 of 0, not a good thing. So let's look at its graph and its table of values though. So I have a screenshot here of part of the graph of sine of x over x. We're used to kind of this curve behavior with sine of x. The fact that we're dividing by x is why it doesn't have that repeating kind of thing going on that we're used to. So it doesn't look like there are any problems, right? It looks like it's completely continuous. There are no vertical asymptotes or anything like that going on. So the only problem seems to be at x equals 0. We have that one little bitty problem at x equals 0. We're good everywhere else. Okay? So the table here, I broke it down. It's not just -3 to +3 counting by whole numbers because that doesn't show us enough detail. So what I did was I did the table set thing and changed how my table counts, and so that we can kind of zoom in on really what is happening here at 0. So my question is, even though sine of x over x is undefined at 0, okay, it is undefined. If we get 0 over 0, that's technically the answer to that is that the function is undefined. We can't find the value. Okay. Even though it's undefined right there, where are its y values headed? What are the y values getting really close to as we get closer and closer to x equals 0? 1. Okay, they're getting closer. We can see it here in the graph. That's y equals 1 right here. We can see it in the table. They're getting closer and closer to 1. So that is really what the definition, okay, y equals 1 is the answer to that question. So this is what we call the limit of the function at x equals 0. Okay, the limit of the function at x equals 0 is the y value that the function is approaching as your x values get closer to a certain x value. Okay. I just wanted to focus on that one problem at x equals 0, but we could talk about the limit of this function at x equals pi. We could talk about it at x equals -2. We could talk about it at any x value. But most of the time we talk about limits at certain points of interest, such in this function where it's undefined, okay? So here's your notation for the limit. We abbreviate it LIM. This X with the arrow is kind of a subscript. I can't get it close enough to the limit there, but it's literally right under the limit of f of x. So you read this, the limit as x approaches 0 of f of x is equal to 1. So that was this specific limit right here. Our function is sine of x over x. The limit as x approaches 0 of that function is 1. Okay, so let's find some limits of some functions. Most of the time, the majority of the time, you can just evaluate a limit by plugging in the given x value. So if our function is f of x is equal to x squared minus 3x, and they want us to find the limit as x approaches -2 of that function, the majority of the time, all you have to do is plug in that x value into the function and get an answer. That should always be your first reaction. When they ask you a limit, your first reaction should always be just plug the number in. Okay, so -2 squared is 4. -3 times -2 is +6. So this limit is equal to 10. Now, if I was at a different x value, my function would have a different limit. If I was approaching 0, what would be the limit? If x was approaching 0, the limit would be 0, because when you plug in 0, you get 0. Okay? So it doesn't matter what x value we're talking about, we just plug it in. Okay? Let's do a trig function. G of theta is equal to the cosine of theta. Find the limit as theta approaches pi over 6 of this function, cosine of theta. Well, again, just plug it in. What is the cosine of pi over 6? Square root of 3 over 2. I think we need another unit circle quiz. Cosine of pi over 6 is the square root of 3 over 2. Okay, let's look at a rational function. H of x is equal to x squared minus x minus 6 over x minus 3. Let's find the limit as h of x approaches 1. Or excuse me, let's find the limit as x approaches 1 of h of x. So just plug it in. 1 squared minus 1 minus 6 over 1 minus 3. So 1 minus 1, that's -6 over 1 minus 3 is -2. So it is equal to 3. Now, could we have simplified that rational expression right there? Yes. Okay, we could factor x minus 3, x plus 2. So the x minus 3's cancel. So really, our function is just x plus 2, except it has what going on? What happens when we cancel that x minus 3? It's a hole, okay? We have a hole at +3. So it's just like the function x plus 2. It's going to look like a line. If you graph that rational function in your calculator, it's going to look like a line, except there's going to be an error because there's a hole at +3. So really all we had to do was 1 plus 2. But we get the same answer either way. I just wanted to point that out because that's going to come into play here in a little bit. Okay, how about this last one? S of t is equal to -3. Find the limit as t approaches 5 of s of t. It would just be what? It's just -3. Okay? This function is a constant function. Everywhere we are, the y value is -3. It doesn't matter if x is 5, or excuse me, if t is 5, if t is -10, if t is 0, if t is -100, it doesn't matter. The y value is always -3, so the limit is always going to be -3.